Hello everyone, welcome to our first video for Math 207. We're going to talk about setting up systems of linear equations by using an example. Sort of a toy example, but let's try it out. I've got some siblings, Xavier and Yolanda, and I know some information about them. One thing I know is that in total they have lived 20 years. But I also know that Yolanda is 2 years older than twice Xavier's age. How I know these things without knowing their actual ages, who knows. But it's kind of a fun puzzle. So our goal is to set this up using linear equations and then be able to solve the problem. So the first thing we need to do is know what our variables are. So Xavier and Yolanda will use little letters to make variables that represent their ages. So I'll use little x to describe Xavier's age and little y to describe Yolanda's age, both in years. And now what I want to do is I want to take these statements and I want to convert them into linear equations. So this first one, in total they have lived 20 years, means that the sum of their ages is equal to 20. So I have that x plus y equals 20. This other statement, Yolanda is 2 years older than twice Xavier's age. That means that y is equal to 2 plus twice x. So now I have in this equation that y is equal to 2 plus 2x, corresponding to this statement. So now we can ignore the fact that these statements have anything to do with the equations and just focus on the equations themselves. Another thing that can be helpful is to take the equations and make sure that all of the variables are on the left-hand side and all of the constants are on the right-hand side. So this one is already set up to go, but I'm going to reorder this one. Notice that by subtracting 2x to both sides, I have this equation here. So now I'm going to erase this equation because it's not well formed, but also note that I have all of the terms that have the like variables are in columns, which is really nice for comparing them. So now I'd like to be able to solve this system of linear equations to find out exactly what are the values of x and y that we have, and there are three main methods that we can use: graphing, substituting, and by performing arithmetic on the equations. Let's first try the graphing method, which is nice because we already have an x and a y variable, which means that it'd be nice to be able to solve in terms of y, and then we have a y equals mx plus b type format for our lines. Luckily, both of our equations have y by itself, so all we need to do is to subtract the x terms from both sides to get what we want. So let's perform that and put it here. So now we have our two equations into slope-intercept form. So we see that y equals negative x plus 20. I have a y-intercept of 20 and a slope of negative 1. But also y equals 2x plus 2. I have a y-intercept of 2 and a slope of 2. Which means that these lines definitely intersect, so there should be a unique solution. So just by looking at this, we can tell there is a solution. We don't know exactly what it is, but let's plot to figure out if we can guess what the values are. So now I have plotted an xy axis, and my x is on the horizontal axis and y is on the vertical axis. Sorry you can't see the very, very top, but I've also created some units so we can start to see a little bit about what's going on. So let's first plot this one. I want to use the 20 as my y-intercept. I want a slope of negative 1. So here's our first line, slope of negative 1, and let's put in our second line. Starting at the y-intercept of 2, having a slope of 2. So just by drawing, we see that we do have a slope here, and we do have an intersection point. And it looks like it's somewhere around 5 and 15, which would make sense, right? We know that x plus y equals 20, that's this line. But where exactly this equation does hit is a little hard to tell just from a drawing. Drawings are inexact and doesn't really give us numbers. So we want to do something instead that gives us an exact value. So let's try to get that exact value by using our second method, which is substitution. With substitution, what we can do is we can solve for a variable in terms of the other variable. So what I'm going to do is I'm going to erase one of these equations. Specifically, I'm going to erase this version and look at this version here. I see that y is equal to 2x plus 2. I got that from this equation. So it's important to keep in mind that these equations are equivalent. So this is just this equation rephrased slightly. What I'm going to do is I'm going to take this value for y and I'm going to substitute it into this equation, the other equation, the one it didn't come from. And then by using that, we'll be able to see if we can get an exact value. So the idea is to take y and replace it by 2x plus 2. Whenever I see a y in this equation, I'll replace it by 2x plus 2. So I'm going to write that version right up here. X plus 2x plus 2 is equal to 20. So now let's combine like terms. I will combine the x and the 2x, but then I'll also move this negative 2 over by subtraction. And what I get is 3x equals 18. By dividing by 3 on each side, we find out that x is equal to 6. So now we know that Xavier is 6 years old. We can plug that down now because we know exactly how to determine y in terms of x. I know that y is equal to 2x plus 2. Well, that is equal to, I can take my value of 6 for x and plug it into the equation. 2 times 6 is 12 plus 2 is 14. I can say that y is equal to 14. So therefore, my drawing is slightly off in terms of proportions. It's supposed to be 6 and 14. So the drawing was close, substitution method definitely worked. Well, during lecture we were talking about how to add equations together, and let's just see another example of that. So let's start again with our initial set of equations. Here we are with our initial two equations, and what each of these says is separately, this first equation says this left-hand side is always going to be equal to this right-hand side. This equation says that this left-hand side is always going to be equal to this right-hand side. But that also means that if I take any combination of this left-hand side and this left-hand side, and I perform the same combination of this right-hand side and this right-hand side, what results on each side is going to be the same. So I can perform arithmetic across equations by doing left-hand side, right-hand side. So what we would like to do is discover some common structure inside of one of the sides and remove it, try to simplify, hopefully try to remove a variable is usually what we want to do. And if we notice, we see that we have, in the y variables, we have the same term. We have plus y. So we can remove that if I subtract this equation from this equation. So the idea is I want to take these terms, negative 2x plus y, and I want to subtract that from x plus y, and I want to subtract 2 from 20. So I'm going to take this equation, I'm going to subtract it from this equation. So I will do the subtraction on the left, subtraction on the right, and I'll still have an equality. So let's do the right-hand side first, because that's easier. We see we have 18. 20 minus 2 is 18. On the left-hand side, I have y minus y is 0y. Y minus y is 0y. But with the x, I have x minus a negative 2x. Minus negative becomes a positive, so I have x plus 2x. We have 3x. So 3x plus 0y is equal to 18. And remember that the 0y just disappears. So I have 3x equals 18. And then we see this implies x equals 6. And now we can plug this 6 into either one of these equations, and we can discover what we want. Right? So these are both, all three different methods got us either close to the answer or got us to the answer. Again, if I plug in x equals 6, I will see that 6 plus y equals 20, so y equals 14. So this pair together is our answer for our unique solution to this puzzle. But all three methods got us definitely knowing there was a unique solution, and two of the methods got us exactly the value. The next time we'll be able to see this except with three variables.